Students from India should use data from India. Students from an African country should use the data from their African country, not from North America. They need to solve the problem in their country, where they live, where they have social responsibility, and also where they have local knowledge, because hydrology requires a local knowledge.
And we need people to do analysis from scratch, but then they need to do the forensic analysis of floods, catastrophic floods as well, looking at local conditions. And that's where we're kind of completely seeing a gap in the developing country context.
Water management and flood risk management is not an invention of the last decades. It has been practiced for millennia in many parts of the world. Actually, in some Asian countries, much longer than in Europe, such as in India and in China.
Welcome to the Water Data Podcast, where we talk about the science, the stories, and the systems that shape our water future. I'm your host, Veena Srinivasan. Every couple of weeks, we'll chat about how better data and evidence can result in better decision-making and ultimately better outcomes for people and the planet. So if you're a student, a researcher, an innovator, a practitioner, or just curious about how we can better manage this precious resource, you've come to the right place. Let's get started. Welcome to the Water Data Podcast. Today, it is an absolute honor and privilege to be speaking to Professor Guenter Bloeschl. Guenter Bloeschl is an absolute luminary in the field of hydrology. For anybody who is in this field, he needs no introduction. But most importantly, and most recently, Guenter is the recipient of the 2025 Stockholm Water Prize. And as we're recording this in the weeks in the lead up to the Stockholm Water Prize, it's a real honor, and we're really grateful, Guenter, that you were able to make time for us. I'm sure in a very busy schedule. So, welcome to the Water Data Podcast.
Thank you very much. It's a real pleasure to be here with you.
Thank you. So, Guenter, let me explain a little bit about why we started the Water Data Podcast. We, in a country like India, we find that our hydrological culture is very modeling based and not data based. And one of the reasons and one of the specialities of the work that was done by you and Siva and others through a whole, several decades of work was really to kind of look for signals in the data and then understand what's the data telling us. And you've got 3 decades of work of looking at the issue of floods and flood risk in Europe in particular, but then with insights globally. And I thought we could start with that work, which is, of course, one of the reasons that you've been awarded this prize as well. So I think let me start very, very broadly, because one of the things that you've done over, I want to say several decades, because it's dozens and dozens of papers, is to really show the trend in floods, spatially, temporally, looking at small events and large events, looking at the scaling effects and so on and so forth. So can we kind of start off with what made you start looking at this problem? And also what I would say is it's such a pleasure reading all of your stuff because it's visually beautiful. Unfortunately, it comes across in all of your presentations, all of which we will link. So let's talk about the inspiration behind the work to start with.
Yeah, thank you for the question. The inspiration has been twofold. One, of course, a professional inspiration, because floods are very important, not only in Europe, but worldwide. And better understanding floods means also better being able to predict floods, both at the short term for managing floods during the event, but also the long term for better planning and making the population flood safe. That's one inspiration. But then the other inspiration is more personal because I like patterns. I like the patterns of the water. So you mentioned the layout of my figures and the visual appearance. I'm also a bit of a painter. I like to paint landscapes. So the visual appearance generally of water is very nice. It's aesthetically pleasing. That's my other inspiration for becoming a hydrologist and for particularly working on floods and water more generally.
Firstly, I did not know you were an artist, although I've known you for some years now. But it's also lovely to know that art was your inspiration, because the way you depict flood risk and visualization of flood risk is just visually stunning. So let's kind of now slowly start to unpack all of the pieces that you did in your work on European floods. Firstly, you found, can you tell us about what you found about the spatial dimensions and then the scaling dimensions between, short return period and long return period floods, and then the drivers as well? Maybe we can, go through each of those one by one.
Yes, one of my earlier work together with Siva Pavan has been about the scaling of floods. We were interested in how the floods in small catchments compare to those in larger catchments. And that's a relevant question because we have usually measurements in the big catchments, but no measurements in the small catchments. But much of the infrastructure and the risk does occur in the small catchment. So it's practically important, but also scientifically interesting because it has to do with the processes of aggregation, which relevant processes not just in the water science, but also, for example, in psychology. What is the behavior of a group of people, sociology, as compared to the behavior of individuals? How do they aggregate? And often this interaction is very nonlinear across scales. In hydrology, we have a similar problem. And it's not just a random process, but there's some organization and patterns that lead to the behavior at the larger scales. So this has been the motivation for my interest more generally in scale issues and also as reflected in the floods. And what we have found that indeed floods in small catchments are different from those in the larger catchments for a number of reasons. For example, different atmospheric flood generation processes, particularly in Europe. The small catchments are more prone to floods to convective events, while in larger catchments we have more synoptic events. So there is a scale dependence. And then quantitatively, how this scaling hammers out has to do with the space and time characteristics of the events. So it means how large an area does a rainfall event cover? How long is the duration of the rain event as compared to the space and time characteristics of the catchment? That is, how big is the catchment in space and how fast does it respond to the rainfall event? And this interplay of these space and time scales of the rainfall with those of the catchment then determine the characteristics of the scaling and how we can estimate the floods in the small catchments from those in the large catchments.
Fantastic. I'm just going to have you unpack it a little bit because a lot of the listeners of the podcast are not necessarily hydrologists. A lot of them come from policy backgrounds or other backgrounds. So when we speak about smaller catchments, of course, it doesn't take long for the raindrop to go from the point at which it hits the ground to the stream. And so that's where you're going to see a lot of flash floods, right? Because I think that was...
Exactly. Short response of the catchment to the rainfall means that the travel time of the raindrop in the catchment is short, mainly because the travel distance is short from where the rain falls on the ground to where a flood may hit. So it may only take a couple of hours, or even in an urban catchment, a couple of minutes for the water that falls as rain to arrive at the location you're interested in. This means a fast response. And for these catchment, urban catchment, very often it is convective events, which means thunderstorms, where a lot of energy is in the atmosphere and we have an updraft of the air. Thunderstorms where the local, very high intensity. And because of the short duration of these events, these are those that produce the flash floods in these small catchments, urban catchments, also maybe urban, or maybe also small rural catchments or mountainous catchments. So that's the effect of the relationship between the variability of the rainfall with that of the catchment. It sounds a bit theoretical, but it has really some very practical implications for designing infrastructure, because exactly through these relationships, we can estimate how big a flood's likely going to be. What is the protection level we need in the small catchments? What is the land use planning, regional planning? Where can we build, where can we not build? Has important policy implications.
Right. And of course, in these smaller catchments, the land use really matters because you can easily have a catchment that's entirely urban or that's urban or a ranch versus in very, very large catchments, they're almost always going to be a mix of many, many things, and overall land use doesn't change that quickly. While in a very small area, it could change. You could have, in India particularly, new cities sprouting up every day. So could happen,
Exactly.
very quickly. Okay, so as you then go to the really, really larger catchments, what do you find?
As we get to the larger catchments, these processes of the small catchments, they aggregate. And they aggregate in a linear way. It's like a jigsaw puzzle where the entire image emerges as the sum of these little pieces of the jigsaw. And in a catchment is like that. We have runoff that is produced on the hill slopes and the small plots of lands, and that flows together. So it's a confluence, and then it depends which parts of the river basin contribute how much water, which has to do with the soil characteristics, of course, also with the rainfall, but also with the timing. Which of the water arrives first or arrives later? So this relative timing then determines how big the floods are in the big river basin, in addition to the rainfall, of course. And a new process that comes in as we move from smaller to larger scale, it's flood plain processes. So typically a flood wave travels down the river system, which means higher water at the crest of the flood wave. You see the rising water levels, and in some stage peaks, and then there's the recession after the peak. And if water then spills over into the floodplain, this will change the shape of the flood wave. So it may be a negative effect for those people living in that location where the floodplain is inundated, but so a negative effect locally, but downstream it has a positive effect because the water is retained in the floodplain. And that brings us to an important implication of the floodplain management. If we build levees, so the river water remains in the main channel to protect urbanization, development next to the stream locally, this will have a negative effect downstream because the water is not retained in the floodplain, it remains in the channel and will increase the flood levels downstream. So the new process that comes in, a kind of teleconnection, what happens upstream matters downstream. Again, with policy implications, but somehow there's a need for communication, a balance of the interests, because it's plainly clear that downstream people are interested in water being retained upstream. Upstream people are not. It just will partial the flood waters downstream.
Right.
So it's an obvious conflict of interest which needs to be balanced, mainly through political processes.
Got it. So let me still unpack what you said on the large catchments, because firstly, in small catchments, it's very easy for people to understand why flooding happens because it's a tiny little catchment. You've either urbanized it or whatever. It rains, water reaches very quickly, makes sense. In large catchments, you don't expect that process to happen because it doesn't rain everywhere all at once. It rains in different places. Some places send away water fast, but other places the water gets retained. And overall, in a large catchment, you don't expect to see as big a flood. So, but the processes by which firstly flooding happens in a large catchment, you found over all of that are fundamentally different, right? So can you walk us through why does flooding even happen if it's so heterogeneous? All of that should cancel out, right? It should rain at different times, and so it shouldn't all arrive at the same time. So why does it happen at all?
So it's this accumulation of the flow in a river basin is similar to the national budget of a country. Not every citizen contributes the same way through the taxes. Some citizens do not pay taxes at all. In others, at higher incomes, they will pay more taxes. And the floodwaters at the outside of a big river basin is exactly like that. Not all plots of land will contribute the same way. Some will contribute disproportionately, others will not contribute at all. So that's how this cumulative flood water comes about. And then there's the effect of the timing, whether this flood generation is synchronous, so happens at the same time everywhere, or the timing of the the runoff generation is dispersed in time. This again has a practical implication, particularly if there is a meteorological situation where the storm remains stationary. And that's often is the case in monsoon, for example, or also in Europe when weather systems are blocked by atmospheric processes, then it keeps raining on the same spot for a day, for 2 days, for 3 days. And these are the most dangerous situations for floods in large basins because the storm doesn't pass on to another catchment, just stays there. So a stationary storm, a stationary rainfall is the most dangerous situation in the large river basins. If just people keep paying taxes every day, not one day yes, another day not. They just keep paying the taxes every day, and then the national budget would be superb. We would get a lot of money. But in the case of flood, it's a negative effect as opposed to the budget.
Right. Okay. So I think one of the really cool pieces of your work was also to find that there's a narrative which says that under climate change, rainfall extremes are going to be increasing everywhere. But your research does not show that flooding has in fact increased uniformly everywhere across Europe, right? It's very the actual frequency and intensity has changed over time in different ways in different parts of Europe. So can you explain some of your spatial understanding to us?
That's exactly as you're saying. I will first explain the situation in Europe, but these findings, they also scale up to the entire globe. So this finding also applies to the rest of the world. So what we're seeing very much in Europe, that we have increases in the rainfall in the northwest of Europe, and this has to do with changed storm tracks because the North Pole, the North Polar area is warming up more than the equator. There is a change in the atmospheric pressure differences between the pole and the equator, which makes the storm tracks slide further to the north. The storms that bring the water from the northern Atlantic to Europe, because much of the wind goes from west to the east. So they slide further to the north, which means that the British Isles, for example, Scandinavia, these regions get more water, more rainfall. But on the other hand, the Mediterranean, the south of Europe, is drying out. So this is the effect that produces bigger floods in the northwest of Europe, like northern France, Germany, Scandinavia, England, Ireland. But the same effect produces also that the Mediterranean is getting less water, which increases the probability of the droughts. So we have seen lots of droughts in the Mediterranean, Spain, Italy, Greece, Turkey, also in North Africa in the last decades because of the same effect.
So this is a purely climate change effect. Why is that phenomenon happening? What's the underlying driver of that?
The underlying driver of that is definitely climate change. It is not land use because these large-scale processes, continental-scale processes, usually really the main fingerprint is that of climate. Much less effect of river works, hydraulic works, levees, dams, land use change. You really, at that scale, really this effect is minor. Locally, this can be very important, as we mentioned just before, the urbanization. But at the continental scale, you see the fingerprint of climate. But the question that is not 100% clear, how much of that climate change is anthropogenic? But that's a second question. So it is very clear that it has to do with changing storm tracks, rainfall efficiency, blocking, etc. But what proportion of that is natural climate variability? What portion of that is human-made anthropogenic variability? That still is a matter of discussion. There will, of course, be a human fingerprint in the changing climate, but probably not all of that.
Right.
So that's an interesting pattern. And now the implication of that in the south of Europe is that in the large catchments, the floods do not increase. They actually decrease, and they decrease for two reasons. First, there's no increase in the rainfall of the storms. And second, soil moisture goes down. The catchments dry out because generally there's less water in the system. Evaporation has increased. So in Central Europe, we have found, on the basis of measurements, that the annual evaporation has increased by 17%, 17%, more water lost by the catchments to the atmosphere, which has also implications for drought, very serious implications, but also indirectly on the floods, because at the beginning of the events, the soils are drier, so more water can infiltrate, so the floods go up. But what I just said only applies to the large catchments in southern Europe, while in small catchments, this effect is not relevant, but we see here increases in convective storms. So in small catchments in southern Europe, the floods go up. In large catchments, they go down. It looks like a complex pattern, but this is what we observe.
Right. And of course, if the soil dries out, then when it rains, the soil can take up that moisture. But if the soil is completely saturated, that's when you really get the big floods, right? And what you're saying
Exactly.
is you're getting much less of those complete saturation because of the drying, which is because we have hotter temperatures in southern Europe. And then you find a very different pattern in Eastern Europe, right? So what's driving that?
In Eastern Europe, flood processes are snow-dominated. That is, much of the flooding occurs in spring, so when the seasonal snowpack melts, and the melt water they flow into the rivers and produce floods. So in Western Russia, Ukraine, Belarus, we see lots of these processes, and we can tag, because you were mentioning patterns, we can tag the kind of processes by the time of the year the floods occur. It's one of the patterns also published in Science a couple of years ago.
Another one of those stunningly beautiful figures.
Yeah. What time of the year do the floods occur? This sounds like an esoteric question, but it's very practical. It's not esoteric. And in Eastern Europe, we see the floods they occur between March and April. And because of what? Because it's not the rainfall that actually peaks in summer, not in spring, but because of the snow melt. Now, identified what the process is, we can look at the change of the processes. And because temperatures had been increasing globally by about 1.5 degrees, but in Europe by more than 2 degrees in the last 30 years, and even more than that, particularly Eastern Europe, we can see that now the snowpacks are much shallower than what they used to be 30 years ago. We see much less snow. Even in my hometown in Vienna, in Austria, when I was a kid in the 1960s, in winter we often have snow depth of 1 meter, and the cars got stuck in the traffic because of the snow. My grandchildren now, they've never seen snow in Vienna. So after 2 generations, the situation has completely changed. Actually visually changed, not just on the basis of hydrological data, but visually you can experience the change. And in Eastern Europe, this means there's less snow, therefore less snow melt, and the snow melt floods get smaller. Instead of that, we have rain floods, but they are smaller than the snow melt floods.
Can I ask a stupid question from somebody who lives in a tropical country and has only lived in tropical countries? I would have thought snowmelt is a very slow process, and I would not have expected until I read all of your papers that snowmelt causes flooding in Eastern Europe. Does it all melt at once? I would have thought it's a slow process that could not possibly lead to flooding.
Yes, it's a very valid question you're asking. Snowmelt is indeed a slow process, and the amount of energy that can produce snowmelt, that is the melting of snow to produce meltwaters, is very limited. So you can never produce more than 10 millimeters or 10 liters, 15 liters of water per square meter, which is very little as compared to a monsoon rainfall, for example. You can easily have 100 millimeters of water per day, or even 200 millimeters of water, tenfold amount of water. Why is that still a problem? This is an effect of the social adaptation of people to the floods in the past. So it's not really a physical phenomenon, it's a social phenomenon, because let's consider a river basin. Then people build close to the stream, as close as they can, without incurring too many losses. Historically, so in the past 100,000 years, the infrastructure has evolved in a way that has to do with the flooding, particularly in these riverine systems, with the co-evolution of the hydrology with the infrastructure developed by the people. Now, in regions where you have snowmelt floods, it is true that for a given catchment area upstream of that location, the floods are small, but if you actually live in the city, you don't see the catchment area. You don't know, is this a small catchment, is it a big catchment? You just adapt locally to the water levels. And it is true that there are only 10% of those in other catchment, like alpine catchment or monsoon tropical catchment. It's true. Still, for the people relative to what they are used to, they still can be huge. So these huge flood waves are not produced by a catchment of, say, 1,000 square kilometer. They are produced by a catchment of 10,000 square kilometer. But the effect is the same. And that's why it seems per area that the floods are small, but you don't see the per area, you see just the location. And therefore, these floodways can be very relevant in boreal parts of the world. Snowmelt floods are still further in the north the main source of the flooding and very dangerous.
So typically, then for the snow part, for the snowmelt place, the flood would just completely be dependent on the depth of the snowpack. In years where you just had a lot of snow, all of that would melt and it would just accumulate downstream, and then you would get a flood.
Exactly. The main effect is how much water is stored in the form of snow in the snowpack. Of course, it also has to do with how quick the warming occurs, how much energy is available per day. But very often, at least in northern, not at the pole, but in northern latitudes, very often is the availability of the seasonal snowpack that limits the amount of snow melt. Further in the north, closer to the pole, then the amount of snow is not so much limited, then it's more the energy that limits the amount of snow melt. But then these are not densely populated areas, so society not as important as those where the shallow snowpack is the main indicator of climate change.
Right. So that's really fascinating because again you found that you have firstly different signatures, but then also different processes that drive floods, and that's why, because the different processes are evolving in different ways, the floods are increasing in some places and decreasing in others. So that's kind of really interesting. Now I want to ask a question about, since you already started talking about the sociohydrology part of it, and the damage that floods cause, which has also been a big part of what your work has been. And you've talked about, on one hand, just how many lives are lost, and then how much damage is caused to property. And I think one of the things you've found is that those are two very different types of impacts, and our ability to protect those two is very different. So can you talk a little bit about the impacts of floods, so the risk part of it?
The risk part effect of the floods. That has to do with the magnitude of floods. What is the water levels we expect in the case of the flood, and then also to do with the values that are in the floodplain. That is the infrastructure, the houses, on the economic part. On the social part, it has to do with the people. Let's briefly talk about the economics first. In order to reduce the risk or the potential damage, we have two possibilities. We can reduce the water levels, for example, by retaining the water in flood retention basins, building levees, changing the land use. So various ways of reducing the potential flood levees. That's one way. Or alternatively, we can reduce the assets, the values in the floodplain. For example, through land use planning. So in simple words, it means don't build where there's a flood risk. And this is one of the safest ways of approaching the flood risk problem. Just go away. Don't stay where it is dangerous. So that's
don't put expensive stuff where you're going to get a flood.
Don't put the expensive stuff. Just use the floodplains as agricultural area, for example. That's less expensive. It's damage. But of course, in many parts of the world, the pressure on the land is very high. It certainly applies to most of Europe. Just land is becoming very expensive. And because of that, in theory, it's easily said, easier than done, because who is going to pay for that? not only who's going to pay for that, but how can you implement it politically if people are unwilling to offer the land for changed land use or regional planning? So that's on the economic side. Now, on the human side, even more important to my mind, and as we've seen in some big floods even in Europe, it's not obvious or self-evident that this is not a problem in Europe, even though the flood management is very well developed. We've had two big floods recently in 2021 in Germany and 2024 in Spain, with more than 200 victims. It's a huge number. These were the largest disasters after the Second World War in Europe. So really huge disasters in countries that are very well developed. Still a problem. And this aspect of flood risk has, of course, also to do with the protection measures and management measures and the ability to forecast the events well. This is a task of the hydrologist, because if I have an accurate forecast, then I can choose the timing of evacuation, filling reservoirs, for example, emptying reservoirs in an efficient way. So forecasts are very important. And we have seen in the 2024 event in Austria that the flood forecasting system that my university, the Technical University of Vienna, has developed has worked very well. It really has helped in reducing the flood risk downstream. So it's one element, the more technical element. But there's also a very strong social facet to it, because out of the 200 people that died, both in Spain and Germany, half of them died because they went down into the garage to save their car. And this half of the victims, interestingly, mainly male people. So it's where like 95% male people went down to the garage to get their car. And this has to do with a lack of education. So it's not just building dams, changing land use, or regional planning that helps, which are all good things, but then also education, awareness building among the citizens, because it's the citizens who are at the core of all these flood risk problems. And if they know how to behave, what to do during a flood, not just being scared and panic, because most of these people have indeed panicked without thinking rationally through the problem and the risks involved, then this can be a huge contribution to saving lives.
Are you enjoying this episode? If you are, please hit the subscribe button on your favorite podcast app. Your reviews on Spotify and Apple Podcasts will really help us out. And if you can think of a friend, a colleague, or a fellow water enthusiast who might enjoy it, please do share this episode with them. We hope to reach many more changemakers like you.
You said many, many, many different things. I want to unpack, a few of the things that you said. So firstly, in the really, really long run, the only sensible thing to do is not put expensive stuff where floods are going to be, because they're going to come. They're going to come anyway, and and we already know which areas are flood prone from historical data. But you said that a few things. One of them, but in the short term, once that you've already built it, you talked about the role of levees, and then you talked about the role of dams. Now, in our earlier work, in the earlier conversation, when we were talking about the causes of floods, you didn't actually talk about dams at that time. And I was wondering whether we could go back and maybe said, what is the role that dams play in Europe today in being able to mediate floods? Is it very significant, or is a vast number of catchments which are getting flooded really just don't have any large infrastructure on them and can't do anything? So what fraction of them are regulatable through infrastructure?
Yes. So in Europe, the situation is that a lot of hydraulic infrastructure has been built in the last 100 years, mainly since the beginning of the 20th century. Reservoirs, that is dams, in the north of Europe, mainly because of hydropower production. In the south of Europe, mainly for irrigation. So these are the main purposes of all these reservoirs. There are also retention basins that have been built for reducing the flood risk in the small catchments only. So we're talking about catchments of a couple of square kilometers, not hundreds of thousands of square kilometers. However, the reservoirs that have been built for other purposes, irrigation and hydropower production, they can also make a contribution to reducing the floods. But this depends on how they are managed. Because if you keep them full all the time, which is an advantage, for example, for hydropower production, because the hydropower generated depends on the difference between the water level of the reservoir and the downstream water level in the stream. So there's an incentive to keep them full. But for flood protection, this has negative effects because there's no water, no space available in the reservoir to take up the flood waves. So there is a trade-off between some of the uses, irrigation and hydropower production, and the contribution of these reservoirs to flood protection. In some countries in Europe, this trade-off was made explicit. For example, the government is paying the operators of the reservoirs to keep the water levels down so that these reservoirs can make a contribution to reducing the floods.
So they're privately owned reservoirs then?
Yeah, they're usually privately owned, yes.
Okay.
Or by companies that are owned by the state, but still they're operated like private companies. And then the effect of this retention of the flood waves can be very significant immediately down of the structures. Can reduce the flood peaks like 50%, 80%. It can have very significant effects. But the further you go downstream, the more gets this effect diluted. So at the regional continental scale, you would see, yes, there are individual locations and reaches of streams where you have a very clear effect of this mitigation of the floods by reservoirs, but not everywhere. There are many other places where the reservoirs are so far away, or there are no reservoirs upstreams, where you do not see these effects. While the climate change effect you see everywhere.
Right.
They're not localized. They cover the entire continent. So that's the difference between the reservoirs and the climate change effects.
So the reservoirs are one way, and then you also talked about sort of levees. What fraction of Europe is kind of protected by levees at the moment?
So the rule of thumb is that flood retention basins, lakes, artificial lakes, are most efficient for small catchments. There are small rivers that produce flood waves with a small volume. For these catchments, typically people build retention basins to take up the flood waters. For the large river basins like the Danube, the Rhine, you could also build retention basins, but they're not efficient because there's so much water in these hydrographs, in these flood waves, that whatever size the retention basin is, the effect downstream will be very small. So instead, people build levees, which are structures parallel to the river. So they are on both banks of the river. The structures
they're just a big wall, right?
Yes, exactly. Big walls.
Big walls.
On both sides, on both banks of the river, that protect or prevent the floodwaters to spill from the main channel to the floodplains. And there are two variants of that. One variant is like fixed geotechnical structure, earth-filled levees or dams. The alternative are mobile walls. So they are only erected just before a flood arrives. And this is also used in some cities along the Rhine and along the Danube. So usually you take them down. Then if there's a forecast that a flood arrives, they're built, they're erected. And has the big advantage that usually if there's no flood, you don't see this levee because the levee is not nice. It's ugly.
Yeah, they're ugly. Nobody wants to have them.
Yes, ugly. They use space. And so only erecting these mobile walls during a flood has a big advantage. If possible. But again, two disadvantages. One is you need a very good forecast, which is only possible for the big rivers, not for the small rivers. And then it's not a robust measure as opposed to regional planning. To avoid building expensive things in the flood-prone areas, that's a robust measure because if there's no asset there, you cannot get inundated. But these mobile walls, they're not. And if the water level in the river gets over the crest of these walls, it will spill over and produce even bigger damage. So it's a bit of a risky thing, a bit of a gambling. It will work for floods up to a certain level, but then for the mega floods, it will not work.
So, can I ask a question? Do levees ever breach in Europe, or are they so well constructed that that's not a reason for flooding?
Yes, I'm afraid levees do breach. So most of the big floods we've had, levees have breached. And this has mainly to do with maintenance that's not perfect. Some of the levees have been around for 100 years, built at a time when dam construction was not as advanced as it is now. For example, today, people build in the middle of this levee a screen, which is like an inside wall that's impermeable. And 100 years ago, one did not do that. And then this structure is more prone to be for the water to infiltrate and erode the soils of the dam internally. Also, burrowing animals like rats and beavers, they also can dig holes into the dams. And some of the dam failures we've had in Europe during the last events are exactly because of these burrowing animals. So yes, dams do fail, not everywhere and all the times, but we did have unfortunate situations that in hindsight could have been avoided with proper maintenance. So again, what we see here is not just a technological question or hydrological question, it's also a technological hydrological question, but also very much a cultural question, and a question of governance, and a question of economics, and a question of politics. But both. It has this technical,
and because it takes money to maintain these things. There are many kilometers of wall, right?
It takes money on the one hand, but also the culture of the awareness that is a relevant thing to do, because in a national budget or regional budget, there's always some money, but the question is, what is priority? Where do I set the priority? Do I use the money for schooling or for retired people homes for social purposes? Or do I use the money to subsidize the agriculture or for building dams? Right. And of course, this is a very difficult decision, because also education, for example, is a very important subject for society. It has to do with the awareness, very much with the culture. What importance do we attach to the safety of these structures?
So I want to shift kind of the conversation in a little bit to Africa and Asia, because your own work also shows that the bulk of the floods in the future will actually be in those places, or at least the bulk of the flood damages will be in those places. So to the extent that I know that you said, Europe has a basket of options that it uses to kind of manage flood risk, right? And some of it has to do with like room for the river and just leaving space for the river to grow and not occupying floodplains and land use zoning and so on. Some of it has to do with building walls, either fixed or mobile, and some of it has to do with managing dams more effectively, and then of course running consumer awareness programs, which may not save your property, but at least it will save lives with early warning and awareness. And then, of course, there's insurance, more sophisticated forms of insurance, which will at least compensate you for whatever damage happened. But I think that when we move from Europe, which, with all of the sophistication and the amount of data that's gone in, it still has catastrophic flooding, as we saw in Europe. And now we're coming, with Africa and Asia developing as land becomes scarce in all of these African and Asian cities. You're starting to see lots of construction of floodplains. I'm speaking, from Bangalore in India. Just yesterday, we had catastrophic floods in the northern state of Uttarakhand, where there was a cloudburst and entire towns wiped out, many with casualties. And we see this now every monsoon. It's not a one-off thing that happens, but every few years we see a massive catastrophic event in the mountains. And then Bangalore, one of the highest per capita cities in the country in terms of per capita income, but we saw catastrophic flooding a few years ago where some of the wealthiest homes in the city were underwater. And so, firstly, I would now like to kind of go back and say how you did all of this amazing analysis, and we'll actually link the analysis in the description, the podcast description. But how would we do this in a country where we just don't have the density of hydrometric gauging, stream gauges that Europe had? You had 2,370 or something hydrometric gauges across Europe and long-term records. And I know one of the most painful things was to assemble all of that. What happens in ungauged basins in the developing world, where you don't have adjacent gauge basins to kind of extrapolate from? What should we be doing in this part of the world?
Okay, let me first state. I think it's fair to say that the hydrological processes in Europe and in other continents of the world are not fundamentally different. Of course, in some parts, the color plots, there is no stronger snow effect, and in tropical countries there are tropical cyclones. But by and large, the hydrological processes are similar. The social processes are not necessarily, because there's huge differences in the level of development of various countries of the world in terms of the economic possibilities, in terms of the governance structures, in terms of the culture. And this is where I see the biggest difference across the world between the different continents. I think we can learn from the analyses done in Europe, for example, also for other parts of the world as far as the hydrology is concerned. For example, the scaling I've mentioned, small and large catchments, the same occurs in India and in Africa. There is no difference. These are the physical processes that occur everywhere. In terms of the data, of course, it is an advantage to have observations that are very detailed. And as you're saying rightly, much of the outcomes and the findings are directly related to the availability of the data. There are two things that can be said here. One thing is, it is true that the density is lower in many countries of the world, but they also stream gauges and rain gauges, even though the number is much smaller, and maybe although the records are shorter. So the first thing is to actually use those data, ground measurements that are available. Second thing is satellite data. So satellite data become relatively more important in poorly gauged catchments around the world, less important in Europe, more important in other continents. In Europe, not so important because there's lots of ground data which is more accurate. So the importance of satellite data is not so great. So combined ground stations combined with satellite data. And then the methods that have been developed in places where we have lots of catchments, using methods to transfer flood levels from places where we have measurements to those where we do not. These methods, they are generally also applicable in other parts of the world. So there's an opportunity for a direct transfer of the methods for estimating floods for places where we do not have measurements. My university, actually my group, is running every year a summer school with the topic predictions in ungauged basins. So this is a 1-week summer school where students learn how to do exactly these things on the basis of data in Europe. But these students mostly do not come from Europe. They come from all over the world. So last July, we had the last summer school with 30 students from 18 different countries all over the world. And there's a transfer of methods, which I think should encourage students from all over the world not to use data from Europe or North America. So I feel very strongly about this fact that students from India should use data from India. Yeah. Students from an African country should use the data from their African country, not from North America. And this is not always what you see, because North American data are often more accessible, but that would be the wrong thing to do. They need to solve the problem in their country, where they live, where they have social responsibility, and also where they have local knowledge, because hydrology requires a lot of local knowledge. So I think this is the exchange on the hydrological side of things. On the social side of things, there's still a different thing because the governance structure in some countries in Africa is completely different from those in countries of Europe. Governance is different. The legal situation is different. Even more so, the cultural situation, because you're in any social system, it is not just the written laws, the written norms that determine what's happening. To one part, yes. To the other part, it's the unwritten laws, the unwritten norms, what people are used to, whether actually the norms are applied or not applied, or something different is happening. We see differences in Europe also between the application and the culture in the context of flood risk management, for example. Even bigger differences between the continents. Therefore, for solving problems in some countries of Africa, for example, not only do we have to consider the local hydrology, we can learn from other countries, from Europe, for example, on the methods to apply. We also need to very much give attention to the social situation and legal situation, political situation, which will be very different from that in Europe. So we cannot learn from Europe. We need to learn locally, understand what are the levers to pull in order to improve the situation.
Absolutely, because I think in the, referencing some of the solutions you gave earlier, we find that there's a tendency to copy paste from Europe to India, for example, and a big pushes, for example, towards levees and embankments. But the governance processes required to maintain these, and also just to ensure that the quality of construction is good in the first place and not corrupt, or there isn't money being siphoned away so that the quality of construction is reduced. What you find is much more breaching of levees in these countries, because you just don't have the same quality of construction. You don't have the same maintenance processes. You don't have the same funding devoted to operations and maintenance. You've taken the same solution, but you've not taken all pieces of it. The same piece we find constantly in India with dams as well. What the government departments will tell us is that when the dam is full, nobody wants to take the call to release water, because they're afraid that if the storm doesn't come in the dry season, the farmers are going to go after them. And nobody wants to face the wrath of the farmers in the dry season. And so everybody is delaying till the last possible moment to not release the water. Even though we have the early warning, it may not be as good as the early warning in Europe still, but we have early warning to say there's a big storm coming in. You have data that the dam is already reaching near full levels, but the governance system to take the call doesn't exist. So again, some of these things need to be sort of rethought, and we need people to do analysis from scratch, but then they need to do the forensic analysis of floods, catastrophic floods as well, looking at local conditions. And that's where we're kind of completely seeing a gap in the developing country context.
I could not agree more with what you're saying, because the copy and pasting of Western technology is a very dangerous thing. It ignores the fact that an important determinant of the success of these measures is the culture, which is not the same. So if methods are used from elsewhere, then the focus needs to be on the difference of the culture, and often as you mentioned, the difference of the culture, because these are ultimately the driver for the lower standards. It's not a law that would say, well, the quality of construction in India is lower than that in England, for example. There's no law saying that. It is not necessarily economics either, but it's cultural. So, as you're saying, these things need to be rethought for the local situation, and particularly for the local culture, to get solutions that are in line with the culture that's actually happening in the places of interest. Local solutions have many advantages over more global solutions for being more adapted to the cultural realities we have in the situation. Technocratic solutions, large dams, large levee systems also have an appeal, particularly for politicians who can then say, when the works are finished, they can appear on TV and say, look what I've done for the citizens to protect you. It has some positive incentives, but then whether they work in practice under a particular cultural regime, it's questionable. So local solutions, including those that have some history in the respective countries, because it's also an obvious truth that water management and flood risk management is not an invention of the last decades. It has been practiced for millennia in many parts of the world. Actually, in some Asian countries, much longer than in Europe, such as in India and in China. So referring to the experience of the past, learning, among other things, from the experience of the past can be a good vehicle to getting more robust strategies that are culturally safe.
Yeah, no, absolutely. And then looking kind of from the past to the future, I was wondering whether you're beginning to now see in all of these countries where data doesn't exist, people using innovative like citizen observatories or using like CCTV camera data or to kind of reconstruct flood levels. Is that beginning? And I wonder whether AI will make a lot of that easier, but are we beginning to see trends in that?
Okay, the responsibility of the citizens, and we do see a trend change here, is more directed towards awareness and local protection measures. So these local systems. We also see this trend in Europe. And also authorities are recognizing more that big dams, technocratic solutions are good, but there can be a very important role for local solution for people to protect themselves. So that's,
right.
I think
because
this is
flooding
a very good.
Tends to be for most part hyperlocal. Or many.
It is yes and no. There is a local contribution, and it doesn't necessarily mean that if your house is built in the middle of the floodplain, and then if you seal the windows, that it would become flood-proof. It depends on the situation, but it can definitely be a contribution, which also helps with awareness, with safety of citizens. So there is a good trend on the management side of things. On the more hydrological, scientific side of things, yes, there are a couple of initiatives of citizen science, for example, for putting together large data sets. One such initiative is the digitalization of historic records that have been published in yearbooks on paper, putting this on the computer. And in this project, these numbers are put in the computer, so data observations from the 19th century, for example, can be used to get longer records. It's one kind of initiative that's happening in a couple of countries in Europe. Another initiative is collecting measurements. And of course, new technologies can help a lot. For example, software that is able to recognize from a camera, video of the camera of the smartphones, the rainfall intensity. And then this is quantified and put into a software and collected on the basis of citizens taking photos at determined intervals of the water level of the stream with a gauge or staff in the background, again, and automatically digitized to infer the water levels from these images. These initiatives exist, but not with complete aerial coverage. So I think these initiatives are in their infancy. There's a lot of promise for them. Probably not yet at the level that it would make a difference for practical flood management. I think we have still some way to go to encourage these initiatives, because we need to remember there is a twofold incentive. It's not only the data that can be ingested and help the other networks we have available, but also the awareness building. So the fact that citizens go out, observe the stream, then there is a water level. It's not the same every year. So this is not so obvious. To hydrologists, it's obvious that there's dynamics, but not to every citizen. So this awareness building, that's another, I think, important component of the citizen science.
Very true. I want to kind of sort of towards the end of this podcast, have you kind of reflect on two pieces. One is your work is really about looking at data and then really making sense of the data and then positioning the data for use so that it actually makes a difference. It kind of goes through the entire phase of whatever, the entire set of steps, the entire life cycle of whatever of data. That's very unusual for a researcher. And it's particularly unusual in countries like India, where, as I said before, I don't think there is a data culture. There's a modeling culture, but not a data culture. And so I was wondering whether you could kind of tell us what you think, a little bit about where you think the future of this lies. So if you had to make a call to action for students starting their career or young professionals starting their career, what would you ask them to pursue? And what's your call to them to engage more with data?
The future is, of course, as you're saying, the young generation. So if you want to change things, you need to change the mind of people, not only legal frameworks, but the way people think, particularly young researchers and young practitioners. And one of the directions where the change should take place is valuing more the role of observations, because it's much easier to run a model, in particular artificial intelligence, and then you get nice pictures, but where's the reliability? Depends on the situation. While observations can be tedious, messy, labor-intensive, so the payoff is not as immediate. But in the long term, they pay very much off because we get more reliable information as compared to the model. So a piece of advice for young researchers and practitioners, don't be afraid of using data. This would be a piece of advice. And also being aware that the payoff may not be immediate, but it takes longer for it to take get a profit, to get a return from the analysis of the data. So don't be afraid of dealing with data, particularly local data. Don't use data from elsewhere. Use the data from where you live, where you work, where you have the local knowledge. So the second piece of advice is use your local knowledge, which, to my mind, with my personal opinion, is even more important than artificial intelligence. So, because artificial intelligence cannot solve all the miracles of the world. It's a tool that can help. In some situations, can help a lot. In other situations, less. Local knowledge is extra, very valuable in hydrology, because hydrology is complex. People say turbulence, the movement of water, is the last unsolved problem in classical mechanics. It's complex, not easy. Local knowledge helps. So that would be my second piece of advice. Use local knowledge, use local data, and then be open to innovation and new ideas. Don't focus on the methods, focus on the problems. And these can be scientific problems, understanding the mechanisms, the functioning of this flood system, how runoff is generated. It can also be practical social problems. Don't solve all the methods. So the wrong way of doing that, my advice to the students is, I have a method like some artificial intelligence, tree structure-based method. Where can I apply it? This would be the wrong approach. The right thing is, I have a problem. I want to understand, for example, how does the flood water level change with changing rainfall? If I double the rainfall, does the flood waters double or triple or quadruple? That's a science question with practical implications. And then use whatever method you think is appropriate, not the other way around. Third piece of advice.
Fantastic. Guenter, I think you really, really left us with a lot of inspiration. I only feel bad that this is a podcast where people can't see all of those beautiful images from your papers. So we're going to link a lot of your presentations because, as I said before, your soul of an artist really comes through in your work. But thank you very much for these inspirational words, because I feel the work that you've done, and of course with Siva along on the pub and social hydrology as well, although we focused only on your flood work today, has been so influential in my own thinking and my own career that I can't express enough my gratitude to both of you in kind of giving that early direction. But I hope it would be likewise inspirational to an entirely new generation of young water professionals. Thank you, Guenter. It's been a pleasure chatting.
Thank you so much for the kind words and also for the opportunity just to share my ideas here in this forum. Thank you again.
That's it for this episode of the Water Data Podcast. Thank you for listening till the end. If you enjoyed this conversation, please subscribe to the Well Labs YouTube channel and share this episode with your friends and colleagues. You can find the Water Data Podcast on all major podcast platforms. Until then, stay curious and stay connected. Thank you.